Hi, good evening, everyone. Welcome to the WeCloud Open workshop. So tonight we're going to introduce everyone to SQL. I'm going to give you an hour-long lecture on, SQL fundamentals. This is part one of the the three-part, SQL like open class, and hopefully we can walk everyone through, the fundamentals of SQL, how to write queries and how to query databases and doing joins and aggregation. That should help you get started with SQL. And to access the learning material, you can access learn.weclouddata.com. And let me tell you how to access the learning portal. But basically, you just go to learn.weclouddata.com. If you don't have an account, you can click on sign up. If you happen to have registered in the past and forgot the password, then you just click on forgot password and you can reset the password. I'm just gonna, oh, 1 second. Let me try to log in. Just bear with me for a second. Okay, sorry about the pause. I just recovered my password. So you can log in and you will see the welcome page. So by default, you don't have access to any learning material. So you can just click on WeCloud Open on the left-hand side. So these are WeCloudData's open courses. So they're absolutely free. We have open workshops. So you can, if you filter on open workshop, we have different topics: business intelligence, data science, data engineering, and DevOps engineering. We usually do the workshops on Fridays. And then we also have the self-paced courses. So last week we launched the SQL open course. It's self-paced, and I think a while ago we launched Python. So today I'm going to walk everyone through the SQL course, and you can just click on Introduction to SQL. I'm already enrolled in the course, so I'm accessing the material directly, but you might see like an overview page and ask you to self-enroll. So you can just click on the button on the top right corner, and then you should be able to enroll yourself into this course. We will keep adding exercises and useful material to this open course. And the objective of this course is just for career switchers to get started, with SQL. And or for business professionals who are more comfortable with Excel and would like to upskill yourself to work with bigger data set that's stored in databases. This can be a really good course for you to begin with. There's some useful links. You can follow us on LinkedIn and YouTube. But if you would like to, ask questions and get some help or join our Discord community, you can click on this link to join the SQL free SQL course channel. We plan to do 3 cohorts this year. You guys are, I think this is the first part, which is Introduction to SQL tonight. If you're interested in the ones, in the coming weeks, basic SQL queries and also aggregations and joins, you can click on this link to sign up for this course. It's a basically Zoom registration link, and you'll be able to put this in your calendar. To navigate through this course, the panel is on the right-hand side, and we have 6 modules, and we'll keep adding more. Yeah, so today I'm going to give you a quick introduction to data and databases. And the recordings, these are, self-paced courses. So our instructor, Tianshu, has already actually recorded the whole session. So if you would like to, move faster, you can just go through this on your own. And each chapter will have recordings, and there will be slides as well as exercises. So feel free to go through this course. If you have any questions, you can ask them on the Discord channel. Okay. Yeah, so that's a quick introduction to WeCloud Open. And this year we plan to launch data science course as well as free machine learning lectures. So stay tuned. I think they will be available pretty soon, and it will let everyone know once it's available on Discord and on LinkedIn as well. Cool. Let's get started. So, by the way, I think today is Tuesday, right? So yeah, so this Tuesday, the coming Tuesday, and the one after, next we have the SQL open, like live classes basically of the free SQL course. But Fridays, I think this Friday, in the next like 3 Fridays, we are going to cover introduction to Python. So if you would like to join like live classes, you will be able to find the schedule on the learning portal as well. So if you just filter on self-paced, go to introduction to Python, I think the schedule has been posted here already, and you can sign up for those. We may send out some email campaigns just to remind everyone about the course, about the class schedule, and then you will get a link through the email as well. Alrighty, let's get started. There are 2 presentations I would like to go through today. So there's no hands-on lab today. I just want to cover like the basic concept first, and then I'll give everyone like some sort of assignment. Like you have to preview before you attend the next class. You have about a week to do that. I'll tell you what what material you need to go through, and before next Tuesday, because Tianshu will be teaching next Tuesday and the one afterwards. It will mostly be hands-on lab, so you need to follow along. You need to have like SQL Workbench or Data Grip installed. WeCloudData partner with JetBrains, so we are going to share the link with you. But basically, you'll get access to the JetBrains, the whole suite of PyCharm, Data Grip, the tool for I think the licenses for education licenses for 1 year, so you have like a 1-year license. We'll put that on the learning portal as well. Okay, but make sure you install the software before you join the next class. And today it's mainly theory, but you can watch the self-paced recording as well. Okay. All right, let's talk about data and databases. So what is data? Data is a set of values about one or more persons or objects. This is probably too abstract, but I think we deal with data every single day, right? We use TikTok, we use WhatsApp, Facebook. Every mobile app we work with, it generates data. But when we walk around like in the cities, we're being tracked as well, and different countries will do this kind of tracking to various degrees. But for example, for traffic management, like sometimes you get tickets. Well, that's because it's being recorded, right? If you cross the red light. So all of these, every activity we do nowadays generate data, and all of these are digital data. Some of these data is structured data, and some of those are semi-structured and unstructured data. Now, quick question to everyone. Can you give an example of structured data and semi-structured data? Feel free to unmute yourself or send send to the Zoom chat. Excel spreadsheet equals structured. Yeah, I totally agree with you. That's usually how I understand structured data. So basically you have rows and columns, right? The data is structured. We can turn unstructured data into a structured format as well. But yeah, typically the data we store in Excel spreadsheet, in CSV, right? And data we stored in a relational database, these are considered as structured data. Yeah, tabular data as well, same thing. How about semi-structured data? Any examples? Yes. voice recordings, image data, and text data. These are, videos. These are all unstructured data. HK, yes. JSON, JSON data, XML files. These are all semi-structured data. Makes sense. So, so for example, like if you come to this page and then you click on view page source, that's basically HTML, right? So this is actually semi-structured data. Okay, it doesn't like you can well, when we do web scraping, sometimes we can store the entire text, right? This blob of text as one column in Excel spreadsheet or in CSV file. So you can look at you can think of that as a structure file. But the issue with that is, if you have the whole, XML or HTML file as a string stored in an Excel spreadsheet, it's very hard to work with this column, right? So we need to store data in a format that makes it easy for, for analysis, right? Or for some sort of data manipulation. So in this case, it's better to use store the data in a semi-structured format or unstructured way. And in Python, for example, we can store JSON data, right, in the Python dictionary. And Python, the Python built-in dictionary can allow us to manipulate the data really easily. And semi-structured data can be stored in NoSQL databases, for example, and that allows us to manipulate the data a lot easier than doing that in this kind of analysis in a relational database. Okay, and unstructured data, again, we can store all of these data in Excel, in spreadsheet, right, in a structured format, in tabular data. The challenge is that it's very hard to analyze the data, right, stored in Excel spreadsheet when it comes to text. We can do some sort of regular expression, but it doesn't give you the flexibility to do, for example, natural language processing or text processing. And that's why we need to store that in an unstructured way. And there's one type of databases which is called NoSQL database. We'll talk about that shortly. Okay. If we want to store data in a structured way, of course, Excel, Google Sheet, but they have some sort of limitation, right? So you can't really manipulate really large data set in Excel. Of course, when the data is actually stored on a server in Azure cloud somewhere, maybe you can still process that, but it doesn't mean that you're storing all of these data in the Excel spreadsheet, right? The data is stored remotely on a very powerful server. So if we have more data and we would like to store these tabular data, and we would like to have easy access to these data, and then we have to resort to the databases, and these are relational databases. Okay. Another challenge with Excel data is that you can, in Excel we can have multiple sheets, right? And each sheet typically, store one type of information. It could be customer data, it could be product table. Then typically we put them in different sheets, and you can have many sheets, and it's going to grow and become very hard to work with, right? And if we would like to cross-reference data from different tables or different sheets, then we'll have to use something called VLOOKUP, right? If you work with Excel, you definitely know what VLOOKUP means, right? It allows you to look up data based on some sort of key in another spreadsheet. It works pretty well in Excel, but when your data starts to scale, and when the relationship among these different tables and sheets become more complex, Excel is definitely not the best vehicle for us to analyze big data and messy data. So in this case, database is what we would like to use to store data, right? So what is a database? In today's context, we will mainly focus on relational database, because SQL is a query language, right, that we use to interact with relational databases, which means data is still stored in some sort of structured way. Okay, so we're still talking about structured data. We will have a session in the future to talk about non-relational databases. Okay, but let's focus on relational database today. A database is an organized collection of data, and that data is not just the data we would like to analyze. That includes, data about data as well, which is the metadata, right? So schema, tables, queries, reports, database views, and many other objects. Right? In a typical database, we have many different types of objects, and all of these are part of the database. Okay, and I'll explain that in more detail. To store these data in a structured way in relational databases, we need to do something called data modeling, right? So if we work with a data warehouse, which is typically used for BI and business intelligence and data analytics purpose, we have to do data modeling properly. And we can follow some sort of typical patterns such as the star schema, but those are data warehouses, right? In a typical operational databases, it's called something called like entity relationship, right? That sort of tells the end users of the relational database how we would like to organize the data and how different tables. Imagine these tables are just like different Excel spreadsheets, right? How these tables relate to each other, right? Because we're going to do something similar to VLOOKUPs, because it's impossible for us to store all the information we want to process in one gigantic Excel spreadsheet. So we may want to store different information such as customers, product orders in different tables. And we need to tell the database how we would like to connect these different tables. So that's some sort of database data modeling, and it's called entity relationship, okay? What we're looking at right now is an entity relationship, ER diagram, which is, I think it's an example, like a banking example, right? So we have a transaction table, right? So the transaction table stores the account information, like the account ID, the transaction type, whether it's debit or credit, right? Loan ID, employee ID, and there are account related information, right? For example, that in the accounts table, we have a column called customer ID. And we know that this customer ID allows us to connect to a customer table. In this customer table, it stores information about the customer, right? The customer type, the company ID. And if we have a company ID, it links us to the company table where we actually store all the company related information. Okay, so it's actually pretty complex. This is called, a data model, right? And the entity relationship table. If you would like to work with SQL as a data analyst, I think you need to understand how to read this kind of data model or entity relationship diagram very well, because that tells you how you're going to do joins and merging different tables later. You're going to use this as a reference. I've worked for companies that don't have this kind of ER diagram. It's a little bit disorganized. So you sort of need to write a lot of queries or read other data analysts, queries. So you always have this kind of ER diagram in your mind. Like it's like now it becomes your experience. You have worked with many different tables. You know how to join and merge these tables. But ideally, you need to have like an ER diagram that will make everyone's life easier. Okay, and the way we create tables and the way we store data, right, and create an index, it can all be based on the entity relationship diagram. Okay, so that's a database. It's a collection of data, right, and also the relationship, among different tables, and also some other metadata information. Before we jump into the RDBMS relational database, I would like to introduce different types of databases because it can be confusing sometimes, right? On the left-hand side, we'll see the relational database family, right? Databases such as DB2, which is used a lot in the banks, PostgreSQL, it's an open source database, a MySQL database. These are two of the most popular open source databases. And Oracle, is, I think, one of probably the largest database vendor in the world, and then also SQL Server. But SQL Server is the #1 most popular or most used databases out there because so many companies use Microsoft solution. And MySQL is the second most popular, but it is the most popular open source relational database. Okay. And on the right-hand side, we'll see non-relational database. And these are, as you can tell, they are really specialized in storing, non-tabular data, even though they can be used to store tabular data as well. But they specialize, in storing, for example, text data, full text search databases, such as Elasticsearch or Solr, right? There are databases such as Neo4j that's used for, as a graph database, and Cassandra, which is a key value and column family database. These are the databases that are much more scalable compared to a relational database. We can talk about this in more detail in a later session when we introduce NoSQL, because we need to talk about the CAP theorem. So I'll leave it to another session. But today, let's focus on the relational database. These are some of the popular relational databases out there. You don't have to work or have experience with all of these. Some companies, they use Oracle, and I see a lot of companies using SQL Server. So sometimes when we refer our bootcamp students to employers, they will say, okay, we have a project migrating from SQL Server to Azure Cloud. So we need someone who's specialized in writing stored procedures in SQL Server. So they're looking for something that's more specific. But most of the time, I would say, it doesn't really matter which databases you've worked with, as long as you're pretty strong in SQL, because regardless of the database engines and vendors, you're mostly just working with SQL, and they have, different flavors. But 95% of the time, the syntax will be exactly the same. Okay. On the left-hand side, we see the traditional vendor-based, SQL platforms, right? Such as Oracle, Teradata, and SQL Server. They can be used as transactional databases, which means they're used in production, for example, in a banking system, but they can be used as data warehouses as well. Okay. In the middle, we see open source databases such as MySQL, PostgreSQL, and MariaDB, which is kind of similar to MySQL, but it's more performant. And a lot of the startups will probably begin with, open source databases. And Facebook actually runs the largest MySQL cluster in the world, I believe. A lot of the user data is actually stored in the MySQL database. But of course, they use NoSQL database heavily as well. They began with HBase and then later on migrated over to Cassandra. Okay. On the right-hand side, we see relational databases as well. And these are cloud-based data warehouse tools. So in Amazon, it's called Redshift. Redshift is the very first cloud-based data warehouse. Used to be super popular because users don't have a lot of options. Google BigQuery is very famous as well. It's widely adopted by many companies. For example, if your company deal with Google Analytics data and you do some sort of you have the GA3C software where you pay close to like $150,000, $180,000 a year to access the raw data, those raw data is basically stored in the Google BigQuery database engine. And in Azure, it's some, Azure has the SQL data warehouse. And recently there's a database technology called Snowflake that became widely adopted, and their valuation is really, really high. And I think one of the advantages of using Snowflake is that you don't really get locked into any kind of cloud vendors. So it's cross-cloud, right? So you can install Snowflake on AWS, and later on, if your company decide to move from AWS to Google Cloud, you don't have to do too much work there because it's still Snowflake and it sort of help you take care of the migration. But you still get locked into Snowflake though. So yeah, so it's whenever you work with vendor tools, you have to keep this in mind. But it is very powerful. A lot of our companies that we work with, they already start to use Snowflake. Okay. When it comes to NoSQL databases, there are actually 4 to 5 different types, so it can be confusing sometimes. I'll briefly introduce them, and then we will discuss this in more detail in the NoSQL session. Okay. The first kind of NoSQL database is called the document database. As you can tell, they are super good at storing document data, which is typically unstructured, right? For example, if we have text data, we can store that in MongoDB. MongoDB can do full text search as well, which is pretty powerful. Some of the mobile applications definitely they use MongoDB to store the data behind these apps, right? For example, if you have a local search based app, and for each venues, there's the name of the restaurant, the price tags, the ratings, and these reviews or descriptions are all text data, right? So you can store that in a document database, and later on when you search for these text data, it can search because it indexed the data in a very efficient way. So when we search for hot fudge sundae, it's going to return you not only the relevant search results, like the restaurants that serve this kind of hot fudge sundae, but also they can do location-based search. So it returns the nearest stores or restaurants. Right? That's because when we store the data or index the data in the database, it's already organized in a very optimized way so that it allows us to search efficiently. And of course, we can store all of these descriptions of the stores and the titles and names, right, in a relational database. Imagine it's Excel spreadsheet. It doesn't really optimize the storage of text data, which means it essentially just treat all of these as strings, right? So that means if you would like to search for hot fudge sundae, and we happen to have 1 million restaurants in Excel spreadsheet, which I think is the maximum number of rows we can have, right? It literally means that it needs to go through 1 million rows and compare, right, or search the hot fudge sundae 1 million times before it can tell you, return you the best results. So that's definitely going to be very slow. Right? When you have small data set, it's fine. But when you have large data set, and especially unstructured data, we would like to store the data so that when you read the data, it's going to be very fast. Okay, that's document database, and in some way, it's kind of similar to the full text search database as well, but they are still used for different purposes. The second type of NoSQL database or non-relational database is the graph database. Graph database is very interesting, and the performance can be really, really good when we use it to model or query more complex data structures, right? Especially data that has more complex relationships. For example, LinkedIn is a graph, right? Some people call that the economy graph because each object or each entity, they call that entity, right? Company is an entity, and a person on LinkedIn is an entity. And you can have multiple jobs. For some companies, you work for your employees. And so there's the employee and employer relationship, right? So you work for a company, right? But maybe you have founded a company or co-founded another company, right? Or you own your own small business, right? Or maybe you're a freelancer as well. And you graduated from a school, right? And your classmates or whatever alumni, you graduate from the same school. So even though you don't know that alumni, right, because you guys attended school in different years, but that still sort of creates like a relationship because you attended the same school. And that's why when LinkedIn does the people you may know recommendation, right, they take into consideration many different factors. Have you lived in the same city? Right? Do you work for the same have you worked for the same company, or do you currently work for the same company? Right? Are you interested in the same courses, online or LinkedIn courses, or did you join the same communities? Whatever, you follow the same influencers, and that creates an interest graph, right? And so people, companies, schools, courses, user groups, your skill sets, right? All of these are entities, and it's a little bit, it becomes very hard to model this in an Excel spreadsheet because you basically need to have many different tables. For the companies, you need to have a sheet or a table. called companies, and you need to have, employees, you need to have skills, right? But one person can work for, 10 different companies, have 100 different skills, and have, interest in different kind of interests. If you would like to do recommendation, you would like to find similar users, right? Because you always want to recommend, people who share same interest, right, or share same connections. And that becomes extremely inefficient to work with in the relational database, because that basically means that if you would like to find someone who's similar based on 10 different attributes, you have to join at least 10 tables. And we know that in SQL databases, when you do joins, it's going to be super slow. If you're new to SQL, I think you understand that after the first session, the third session, okay? So the query is not efficient. And graph database solve that problem, right? The popular ones are Neo4j, Tiger Graph. They allow you to, again, when the data gets stored in the database, it already optimized, that in a way that when you do the queries, it's going to be very efficient, okay? Graph databases can be used for recommendation systems. It's one of the popular use cases. There's some other NoSQL databases, such as Key Value Store, such as Redis. I think many of us are Twitter users. So when we see the home timeline, or whenever someone tweets something and it gets pushed to millions of, let's say followers, right? These data is usually cached in the Redis database. So it's a distributed key value, cache in memory caching database. And the latency, which means the speed of reading data from this database, is extremely low. So that's very, very fast and very scalable. The LinkedIn recommender system, all the recommendations sometimes can be pre-computed, right? So maybe on a hourly basis or on a daily basis, Netflix will generate a list of recommended movie for you, right? And the next time you log in, let's say, a day later, they're going to retrieve the recommendation from a database called Cassandra. It's a NoSQL database as well. But if we have, let's say, 500,000 people watching Netflix at the same time, it's going to frequently query the database, right? So during the session, while you're watching one movie and you change your mind, you don't like it, you would like to get other recommendations, right? You keep interacting with the app. So in that case, Redis is the database used, right, to cache all of these recommendations, and it can be valid for, let's say, for 24 hours. If you set that to be 24 hours, and then after 24 hours, it's going to clear the cache. So the next time it's going to retrieve from Cassandra database to get the fresh data. Otherwise, it's going to, basically read directly from Redis, which can be much more scalable, and it's going to be faster. Okay. This is usually related to system design. If you're interested in, machine learning engineering or software engineering, you will probably need to study, this kind of NoSQL and in-memory caching databases, which is pretty common topics in system design. Okay. One of the most relevant databases, I would say, is is the search engine database, because we use that every day. When we search for jobs on LinkedIn, on Indeed, we buy tickets, from Ticketmaster, or we go buy something from Amazon. It's all search engine database, right? And most of these are full text search database, which means you're going to store a lot of text data, textual data, right? Or website, even web pages, directly index that in the database. And when you search for something, it's going to return you the relevant results. And Google is probably the most commonly used example. It's basically a search engine, and it's Lucene based as well. Okay, so these are NoSQL databases. They're really good for storing semi-structured, unstructured data. And relational databases are typically used for storing tabular data. Okay. All right, so that's a quick introduction to databases. And now I would like to move on to the next topic, which is SQL and also relational databases. All right, So how do we work with SQL and database? Let's try to understand a little bit deeper about, databases, right? So by the way, if you just joined this session, this is a WeCloud open, live SQL class. You can go to learn.weclouddata.com. So the entire course is recorded, so you can access, the self-paced learning material. Today is the part 1, and next Tuesday will be part 2. So yeah, mainly explaining theory today, but next session will be hands-on. So it would be great if you can have SQL Workbench or Data Grip installed. I'll mention that at the end to help you get prepared for the next session. Okay. Yeah, so it's a free course. So you just go to learn.weclouddata.com to create an account, and you can just do the self-enrollment. Okay. And no credit card is needed. So what are some of the components of relational databases? We know it's a collection of data, right, and metadata as well. And we typically call that RDBMS, so the Relational Database Management System, right? So the components here are also called objects, right? So we have tables. So the tables are basically your Excel spreadsheet. But in Excel, we can't really store a lot of the metadata information. So some of the metadata information are column names and data types, right? So in Excel, I know like we can have a spreadsheet. The first row on the top is typically the column name, right? And you can select the entire row or column, and then you can change like data format. You can change, a format to be, set that to be like date time format, or you can have like, the numeric value, right? And database is just a more sophisticated, way of managing all of these metadata and the data itself. Okay, so we have tables, we can have views. Views, you can think of views as, just a saved query. And sometimes you need to create view so that you can do some sort of access control, and view can be used for some other purposes as well. I'll discuss that later. Index. Index is very important for a relational database because it affects the performance of your queries. Right? If the data is not indexed, we are always going to sort of read the entire table. Then working with a relational database is almost the same as working with Excel spreadsheet, because one example I gave you previously is that we have a text column, right? And you want to search for some substring or text in this column, then you have to read the entire milling row, and you have to process that and find the relevant information. But if we create an index, it allows us to skip many rows and only jump to the ones that we care about, right? So that allows us to run a query a lot faster. For example, if we can create an index based on the customer ID, right, you can have 1 million customers, and if we're searching for a specific customer ID 123, then it will return the results very quickly because the data has been indexed. Index itself is a data structure, right? And the relational databases typically use a tree-like, data structure to index the data. So when you're going to do the search, it's going to be a lot more efficient. I have some more example later, okay? And schema. Schema has information, for example, the data type, right? And the column names. And these are some of the schema information that are very important because it tells you how to work with these tables.
I'm so sorry to interrupt you there. Can I ask a quick question?
Yeah.
I'm sorry, I think I missed the definition of a view. I'm actually very interested in how it relates to a table, as in really quickly, what is the difference between a view and a table?
Yeah, so when you have a table, the data is physically stored in the table, right? And when you store the data in the table, if you have the index, then it needs to create the index as well. So that takes up some time. But let's say you're going to run a query that joins, let's say you have multiple tables, right? You have customer table, you have product table, and you have orders, okay? And whatever business questions you're going to answer, it probably is going to need data from all 3 tables, okay? So that means you're going to join the 3 tables. And we know that joining the 3 tables may take some time, right? But if this is a transactional system, the table is actually going to keep growing because fresh data will just keep getting appended to this database, right? Because you have new customers every day, your company may have new products, and they will make new orders, right? So the table will keep growing. If you would like to join these three table and generate an output, let's say, now I'm going to join them, I'm going to create a bigger table, and this table gives me all the information I need about the orders, customers, and product. No problem, you can create a table. But once you create the table, right, that information is basically going to be stored in the table, and you can't really change it, right, unless you rerun the whole query. If you have a view, right, you can think of it as a table, but the view doesn't necessarily, of course, they're materialized view as well, but it doesn't necessarily populate the data in the view. So it's sort of more flexible. And in the view, it's basically just a saved SQL scripts. You have a script that joins the three tables. The view actually is basically just a script and that saves. So every time you would like to query this view, it's going to rerun the entire script to get the most fresh data. So your view is always going to get the most up-to-date information. Another use case of view is that, let's say your company work with a consultant, and there's some sensitive information you don't want the consultant to access. Let's say the customer's SIN number or social security number, right? The internal employees, maybe they have the privilege to access those information, but a consultant who's only involved in part of the projects for 3 months, maybe you don't want them to access that information. So you can actually create a view. Let's say your customer table has 10 columns, and you can create a view that only selects the 7 columns that are necessary for that project, for that consultant. And that consultant will only have the privilege to access that view. And every time he accesses the view, it's only going to select the 7 columns. So it's going to exclude the sensitive data, right? So it sort of helps you manage the access to your data. Yeah, so that's another use case of view. Okay.
Thank you so much.
No problem. All right. So, well, let's talk about the first object, which is table. I think this is very straightforward, right? It's just a collection of data represented by rows and columns. So we have rows, columns, column names, and of course, we need to store some other like schema information, such as the data type, right? We can do this in Excel as well, right? But in SQL, the data type or the schema information, like the column. So this is table, right? Column name and data type. So they are stored in the table as well. So we can always access the schema information. So we know, what columns are, included in this table and what is the data type of each one of those columns. Okay. And so that is, the table with the schema information. And again, the schema is, of course, it has more than just, the data types, right? This is MySQL database using the MySQL workbench. So you will be able to see some of the schema information, such as, tables, right? So that means in this database we're working with, these are the table names. So we have customers, orders, product, right? It tells you what engine, right? So this is MySQL InnoDB engine. Tells you the version, row format, but it gives you some summary statistics as well, like number of rows, right? Average row length, and it tells you the index as well, right? And then you can move on to the columns. So it tells you the column name, data types. There will be database triggers, views, stored procedures. Yeah, so all kinds of information that are useful when you run, your queries. For one example here, so. Why do we need number of rows? This is part of the schema information, right? It probably doesn't matter to us when we run some simple queries. We probably never read this table because if you want to tell the number of rows in the table, you can always just run something like a select count star, right, from that table. And that just tells you how many records you have. But this kind of information, such as the number of rows in each table, basically tells you the size of each table, right? And it's used in the SQL internal optimization. So when we run some SQL queries, SQL will actually, it has a query engine. It sort of try to interpret what you're trying to do, right? It always need to analyze the queries we run, because two data analysts might actually write very different queries, even though they would like to achieve the same goal. So their queries will be different. One data analyst can write more efficient query. The other data analyst will run something that's less efficient, that takes more time, right? But the database engine itself is trying to create this query plan by parsing your queries, and it tries to optimize it as well. So it optimizes it automatically for you. It just tries its best, right? It doesn't mean it always gets it right. But when it make a decision, right, on how to optimize your queries, it needs some context. It needs to know more about your table. For example, how big is this table? If you're joining one very big table and a very tiny table. So imagine the table on the left-hand side is very big. It has millions of rows, and the table on the right-hand side is really just a lookup table. It only has like 100 rows, right? And then the SQL query engine is that query planner is actually going to optimize that and use a more efficient way of joining these two tables that can help you significantly reduce the runtime. So that's why this kind of information will be useful, and it's used for query planning and query optimization. Okay, so these are the so-called, schema data. Okay. All right, index. Index, just like the index in the yellow page in a book, right? It allows us to access the information we would like to access a lot faster. That's basically how it works. Imagine you would like to find, let's say, WeCloudData phone number. With Google, it's very fast, right? So you just type in WeCloudData address or phone number, and you'll find that on Google business profile. But Google is a NoSQL engine, right? It's storing all of this in a NoSQL database. It's a very massive database, and then it still indexes the data. And that's why within a couple of milliseconds, Google will be able to return the phone number and some other information about WeCloudData. Okay, so it indexes the WeCloudData information in its database. We're talking about indexing in a relational database context today, right? So imagine you're looking for for the phone number in a phone book. I don't think we use that anymore, right? And typically, let's say a phone book will have like 700 pages, let's say, right? So if you're going to flip through all those pages to find the right information, it's going to take a while, right? Because you don't really know which page to begin with. The best way to do that is just go to the index page, right? It's typically like, I don't know, 20, 50 pages. And then you can just go find WeCloudData, and then it will tell you that WeCloudData is on page 748. And then you just jump to that page. And on that page, there are some other companies as well, but it helps us significantly reduce the search time, right? That's what index is for. And relational databases does exactly the same thing. So the phone book, the index itself takes up some space, right? Let's say 50 pages just for the index. And then the rest of the 650 pages are for the actual information, right? In a relational database, it's the same. When we store the tables, they take up storage space, but index itself takes up storage space as well, right? So you need a more efficient data structure so that when we look up some records in the database table, it hits the index first, right? And then it finds the right place in our database, like on the hard drive, to find that record. So query time can be a lot faster. Okay, so to understand that, I think first we need to understand how relational databases store data. Okay, I know nowadays we work with this is the traditional hard disks, right? So it's like basically spinning disks, and it's easier to explain using this the traditional hard drive HDD. But if you open a hard drive, it basically looks like this, right? It has the spinning disk, which actually stores the data, and you have multiple of these disks, and this arm here, right, moves around. Okay, it touches different parts of this disk, and when it touches different parts of the disk, it's able to read information or data basically from different parts of the disk, and that's how it can read data. Okay, and of course it's spinning at a very fast speed. So that's why it can read data at a very fast speed. Now, on the right-hand side, you can see that the spinning disk is basically separated into something called sectors. In this case, let's say we have 8 sectors. This is one sector, right? And it also has tracks, right? So we have, track 1, 2, 3, and 4. So this is track 1, track 2, track 3, 4, and 5. Okay. So if you would like to access some, certain data on disk, you're basically accessing, let's say in this case, it's sector 1 and track 4. Or in this case, if you would like to access data here, then it's sector 4 and track 3. And where do we find these data? We use this, this little arm here, right? And the disk is spinning and it can move around to read the data, okay? And typically each block, right? So this is a block, okay? And typically each block stores 512 bytes of data, okay? That's how much data is stored in each block. And if we have, tens of gigabytes of data, then it's going to be a lot of blocks, okay? So that's how data is stored. Now, let's try to understand how, let's try to, so now we understand how data is stored on the disk, but how do we relate that to a database and tables, right? So imagine we have a table, which is the product table, okay? This table actually has 3 blocks. But it has multiple rows and 5 columns. This is column 1, which is product ID, column 2, product name, column 3, product category, product subcategory, and product price. Okay. Remember when we define a table, we need to have the data type, right? And also, the length of the column. That sort of help us define how big this column will be, right? So in this case, it's 10 bytes, okay? For the product ID, because it's like numeric, it typically consumes less, disk space, right? So 10 bytes. Product name, which is a string. So let's say it's 50 bytes and 25 bytes for the category, 25 bytes for the subcategory, okay? And then we can basically calculate how much space we need to store one row, right? It's basically 10 bytes plus 50 plus 25, 25 plus 18. Right? That's 128 bytes, basically, okay? And we know that one block allows us to store 512 bytes, right? So that means one block allows us to store basically 4 rows, okay? So the 4 rows here get stored in one block here, okay? This entire block allows us to store 4 rows, right? Row number 1, row number 2, row number 3, and 4. So that essentially means that if we would like to access product ID 37, which is the 3rd row, we just need to go to block 1, and then we'll read the entire block 1, and then we just find the 3rd row, which is product ID 37. Okay. So that's how the data is stored from a table. Gets stored, on the blocks. And we can have index as well. Imagine you have millions of products, right? So knowing which block has the product ID is hard. If we don't have the index, imagine you have millions of rows, right? We basically need to go from the top and read all the way till the end until we find that product ID we're looking for. And on the hard drive, your disk is basically going to start spinning, and then you start to read from the first block for this table, move on to the next block, move on to the next block, until you find that product ID, right? And it may take you a long time to find that. So that means we didn't store the data in a very optimized way. And index can help, right? So index on left-hand side, this is another table, but it's think of it as a table, but it's stored in a more, optimized way, okay? It's using some sort of tree structure to store the index. And think of it as a pointer. It tells you that product ID, if we create the index based on the product ID, that means in your index, you're going to have the product ID, and it also tells you the pointer also points to the block where you can actually find the data, right? So it tells you that, well, this product ID 15 is in block 1, for example. 35 is in block 1 as well. So next time, if we're searching for product ID 236, and we just need to hit the index first, and the index is going to tell you that, okay, it's in block 2. Now you can skip many other blocks. You just need to go directly to block number 2, and then you just need to read 4 records until you find that product ID that you need. Okay, so index essentially allows us to skip many blocks and only read, right, the block that we need. And that's why the data retrieval will be much faster. Okay, so that's how indexing works. I'm skipping all the algorithm part, and hopefully that helps you understand how that works. And I think I explained this already. All right, now, lastly, I would like to explain some of the database operations. And typically when we work with a database table, right, we would like to read data because we would like to use queries to answer business questions. So that is a read operation. And databases allows us to do something called CRUD. CRUD is short for create, read, update, and delete, right? When we store data in a table, or when we create a new table, we always need to store the data or import the data into that table. That is the process of create, right? So we create a table, and then we populate data in that table. Along the way, we may need to store data in the index as well, so we can look up the data more efficiently, right? So that's the create. And then once the data is created, we need to read, right? And sometimes you want to update some information in a database table, right? And sometimes you would like to delete. So most of the queries are related to CRUD, right? And let's try to understand how CRUD works in the context of index, okay? Again, same table, product table, right? And the data, let's say we have lots of products and it spans multiple blocks. When we create the table, table is created first, and then, so step 1, create the table, right? And then we create the index. Index is always created after the table. It has been created, okay? And when we read the data, step 1, it always hits the index first. Let's say we would like to read product ID 751, right? It's probably the simplest SQL queries. Select star from, let's say, this product table, right? Where product ID equal 751. So next week, we'll learn how to write SQL queries if you're completely new to SQL, okay? But I think it's pretty readable, right? We're just trying to find product 751. We would like to retrieve that row or the rows related to that. So when we run this query, it's going to basically look up the index first because it knows that the product ID is an index created on that, okay? So that means, if we can find 751, this product ID, the index is going to tell us where to find this data on the hard drive. And let's say it's in block number 2, right? And your queries are going to directly go to this block and read the data you need, okay? So that's how database read works. And as you can tell, like if we want to do update, and it works the same way. It needs to hit the index first, go find that record, right? And then it's going to update the records in that block. So it's basically going to go find this row in that block, and then it needs to make an update. Let's say we update the price information. Okay, and for delete, works in a very similar fashion, right? We need to hit the index and go find where this table is, and then we're going to delete that record, but we also need to delete that from the index as well. Okay. So that's in a nutshell how CRUD works. And I think that also concludes today's lecture, which is a very quick introduction to databases. And then in the next session, I think Tianshu will be teaching everyone, SQL. So we'll move on to the SQL queries. But we highly recommend you actually just go through the recording first, so you get prepared for the next class. Because if we go through the same content, I think it's pretty much the same as the presentation we recorded. But for the live classes, we actually, starting the second lecture, we would like to focus more on the hands-on exercises, so you guys can ask questions along the way. So this is how you're going to get prepared for next Tuesday's class. Okay, go finish the first module. So watch the recording. The slides and recordings are available, and do some preparation for module 2. It will be great if you can finish module 2 before next Tuesday. You can already, sort of go through the exercises yourself. And I think this is a zip file, so you can download the exercise. Let me try to download that. I'll show you. So this will be the first exercises you'll be working on. So we're going to use create a database called Superstore. So it would be great if you can watch the recording and follow along, and install MySQL Workbench, and then import all the data set into the database. We have the entity relationship diagram here. I sort of help you understand, how the tables are related to each other. And there are 2 SQL scripts. The first one is working with the database. And see, so in the actual recording, Tianshu is basically going to follow this, right? He's doing some sort of live coding, so you can work with him to write some queries to list databases, create a database, but it's all available in the recording already. Okay, and then the next one will be creating tables. So here are some of the questions and some sample code, but you can find the solutions here as well. Okay, so the solution is the third scripts. All right, so yeah, before next Tuesday, it'll be great if we can finish module 2, and then Tianshu will basically just lead the lab in next Tuesday. Next Tuesday, we'll be covering SQL basic queries, so basically module 2 and module 3. Maybe he'll get to module 4 as well. And then the week after, we'll be teaching subqueries, aggregation, as well as joins. And Tianshu will share some additional exercises with everyone as well. Okay, so yeah, that's about it. A quick introduction to SQL and databases, and I'll save some time to answer your questions. So if you have any questions, feel free to ask. I'm just reading the comments in the meeting chat. Yeah, thanks, Anita. The self-paced course is the same as the SQL Open course. Yeah.
Yeah, I just want to update the others that there are 2 self-paced courses that you have to enroll there's a one at the bottom of the page. Yes, then other one.
Yeah, okay. So this is WeCloud Open. You can filter on self-paced courses. Right now we have 2, right? SQL and Python. We'll be releasing data science and machine learning later as well. So these are the self-paced courses. So it basically has the recordings and exercises. It's just like a Udemy course, right? But we have more hands-on exercises. But the WeCloud Open workshops are basically the recordings of hands-on workshops we do on Fridays. So I think last November we did some some workshops, introduction to Apache Spark, data warehouses. So we introduced like Snowflake. So it has the recording of that event. It has slides and exercises as well. But these are like topic based, right? It's not necessarily a a course. So, but if you're interested in a specific topic, you can always check out this content. But if you click on, I think the boot camps, and these are, WeCloudData's boot camps, but at the bottom, you'll find 2 self-paced courses. It's essentially the same. I think we better remove this later. But thanks to Anita. How could we access the presentation slides and recording? It's basically in WeCloud Open. Let me share the link with you as well in case you joined late. So just go to learn.weclouddata.com, sign up for an account, and you can self-enroll in all of these WeCloud Open courses. Okay. Yeah, we will upload today's recording as well, but whatever I covered today, it's in the course already. So you can just watch the video. If you get the 404 error, it's probably because you're not logged in. But yeah, by the way, if you have any questions regarding like the access to the material, you can always ask those questions. In our Discord channel, we have a channel for free SQL course. There's one for the free Python course as well. When you work on those exercises, if you have questions, just feel free to ask them in the channel, okay? Yeah, Friday evening, we'll be covering Python. So Tuesday SQL, Friday Python, we'll do that over the next 3 weeks. There's a question from Chris. Please elaborate on why Cassandra and HBase are popular for software engineering and machine learning. I wouldn't say that Cassandra is more popular for machine learning, because for machine learning, a lot of times relational databases are used as well. It really depends on the use case. Give me 1 second. Okay, let me so yeah, we actually will have a session on NoSQL databases. But if you're interested in machine learning, in the traditional way, we have data coming from data sources, right? Let's say this is your customer engagement data, right? And most likely it's like a MySQL database, right? That's your production database, and through some sort of ETL process, right, or ELT, let's say data extraction, loading, and transformation, it's going to get loaded into the data warehouse. Now here, for data warehouse, we might be using Snowflake, right? And data warehouse is a way for us to organize all the data we have, right? Because we have engagement data, we have payment data, which is stored in a different database, and we can have user data, okay? And these data will basically be ingested into a data warehouse and gets transformed. Data gets cleaned up, right? And then we have data stored in the Snowflake. And then the data engineers and data scientists are going to create something called data mart, but it doesn't have to be a separate database. But let's say a data mart, let's say for machine learning, right? It essentially stores a subset of the data. This is, let's say, data warehouse, okay? It stores a subset of the data just for machine learning purpose. And this is where you store all the features, right? ML features. And data scientists will be using Jupyter Notebook, right? Python, to build machine learning models. And when you do model serving, a lot of times companies just do the batch processing, which means the data is coming from the data mart as well, right? And then so once you have the model, okay, after the machine learning process, we have the best model we can use for prediction, and then it reads the feature and generates the prediction, right? It generates the prediction. So that's how offline machine learning works. Your features are extracted from a relational database, but it could be a NoSQL database as well. Now, where Cassandra and HBase come into, like the NoSQL database, it doesn't have to be Cassandra. It could be DynamoDB as well. But let's say we have NoSQL database, right? And they are actually used for storing the online features. These are low latency databases, right? So let's say some of the data in real time. Okay, let's say we have some data that can be ingested into the NoSQL database directly. And then it asks for some sort of real-time prediction, and your model will be said to be loaded into your model serving infrastructure, and it reads the online features and generates the prediction in real time. So yeah, depending on the use cases, I think relational databases are more used for storing offline features, and the NoSQL database can be used for storing online features for real-time prediction. But some companies just use NoSQL database to store all of their features. But that means the machine learning process may need to push the features into the NoSQL database. For example, if they use Apache Spark to do all the feature engineering, then Spark will probably need to have a process, right, to push the features directly into the NoSQL database. And it's used at companies like Netflix because NoSQL databases are typically more scalable. So it allows you to have more queries, right, running against the database at the same time, simultaneously, because you may have hundreds of thousands of people who would like to, for example, Twitter. Like there might be hundreds of thousands or even millions of people using Twitter at the same time. They're all requesting some sort of recommendation or customized home timeline. When they hit that kind of databases, there are a lot of concurrent database queries. The traditional relational databases doesn't handle that concurrency really well. Right? It can allow you to have thousands of sessions at the same time. But if you have like hundreds of thousands of people who would like to retrieve some data from the database, NoSQL database will be more scalable in that way. Okay. The serverless, the NoSQL database session. Typically, when we post events, we will post that to. I think now it gets posted to Discord already. So I highly recommend you join our server. So let me copy the link again. That's not the right place. Yeah, click on this link to join, and then on the top left corner, you'll find the events. So now we have 7 events scheduled. Right? And tomorrow we have an introduction to our data analytics bootcamp. I will be talking about data science learning path and portfolio projects. And Friday we'll have introduction to Python, the very basic introduction. And then next week we have the Kubernetes certification guide. Yeah, so you can always stay up to date by joining our Discord channel, and a lot of times we'll send like email campaigns. Basically, just send emails to people who are on our mailing list, and we'll remind them about the the events we have every week. Okay. Do you guys have any other questions? Okay. If you don't have any more questions, I hope you can, just go to the SQL, open course, review module 2 and module 3, get prepared for the hands-on lab next week. So we'll see you next week. Thanks, everyone. Oh, sorry. I think I missed the software. So there are 2 types of software you can install for MySQL. So we will use MySQL database. You can either install the MySQL workbench. So let's see, MySQL workbench. It should be in the open course. There should be an introduction, but here's the link. Install MySQL workbench. It's an open source database workbench. A workbench is basically a GUI where you can actually write all of your SQL queries and check out all the database metadata information. You can view the tables and databases. You can click on this link to install MySQL Workbench. You need to install MySQL on your on your computer as well. So install MySQL Workbench, and if you would like to use a different IDE, which is called DataGrip, it's offered by JetBrains. It's the company behind PyCharm. So yeah, so we have a partnership. So our students will have access to the license for like for about a year. So we will share the license key with everyone before the next session starts. Okay, we'll upload that that registration link to the SQL Open course material.